So those of you that were here in the first part one of this know I'm Greg Kazanza, program manager on the VMM team. Been on the team for 3.5 years, working on a variety of areas of the product, in particular networking, which is what I've been talking about for the last hour and 15 minutes. First session in the two-part series on VMM networking was all about how you set up your fabric infrastructure and basically make the networks ready to use by your hosts, ready to use by clouds, and that sort of thing. Part two is really focused on how do you set up your networks and basically take what I built in the first part and enable network virtualization on that network and enable hybrid connectivity. Hybrid connectivity is this notion that you can extend your on-premises address space into a hosted environment, or if you're a hoster, offer the ability for your customers to do that, and basically make it act like it's really one network. In much the same way a hybrid car, you have a battery and an engine, they act as if they're one engine. You don't think about when you press the gas which one's going to get used. A hybrid network works the same way. You deploy your VM in both places, you get addresses that can talk to each other as if they're part of the same network, even though there's a drastically different technology used underneath. I've got Charlie Wen here from the Windows Core networking team to talk about the internals of a key component of the hybrid network, which he'll be coming up and giving me a break for about half an hour while he talks about that. So let's get started. So we introduced a lot in Windows Server 2012 and in VMM 2012 SP1 around the area of hybrid networking. So the idea that you can create a network using network virtualization that's isolated from or that's independent of your physical address space and lets you create essentially isolated tenant networks. Windows Server 2012 introduced the foundation of that. We support it in Windows Server in VMM 2012 SP1, and we're essentially building on that in R2. But one key difference in R2, how we approach it, is that in R2 we really looked at it as a complete end-to-end scenario for hybrid networking to make sure that from the moment you deploy your Hyper-V host all the way up to offering tenant self-service and the tenant experience to make sure that we have all the pieces needed end-to-end. So we really wanted to close all those gaps and make sure that we had everything together using technology from Windows Server, technology from VMM, and even the Windows Azure portal, bring it all together as one seamless experience across all of Microsoft. So it's really been a great thing to work on, to see all these teams come together to bring this to life. So really quickly, I'm going to introduce what a hybrid network is. You're all familiar with hosted environments. They give you compute, storage, and networking as the physical infrastructure. But for each tenant, those tenants essentially get their own illusion that they have their own part of that data center. They have their own storage, their own VMs, and with network virtualization, they have their own networks. They look like their own, but really underneath, it's all being on a shared fabric that's provided by the hoster. Now, one thing that's unique about the network, though, that's a little bit different from how a VM basically can live its whole life as its isolated little bubble, but it's the network that gives it the connectivity outside of the virtual environment. And when you have a virtual network, that virtual network itself needs to have some way to connect to the outside world. And so that's where you need a network virtualization gateway that essentially fills that gap, that connects the virtualized networks to the outside networks. Now, once you have this gateway in place, then you can deploy your services. Tenants can deploy their own services into their networks. They can deploy them into, and those services will have connectivity outside. Now, there are different types of connectivity that these networks can have, though. One is basically being able to connect back to your on-premises data center through a VPN tunnel. And this is really what gives you this ability to have the same address space in two locations. Now, you have to bring a whole subnet across, or it can be a very small subnet, but you do have to bring subnets because there is routing that takes place in between. But ultimately, what you're ending up with is this connection, and the two networks behave as if they're one. You use the same part of your larger address space within each site, and they can talk to each other. But at the same time, you have this connection to your own data center, and you may want connection to multiple of your own data centers, different locations. You don't want to hop through one to get to the other. If you have a failure at one site, you still want to be able to talk to the other. So you want multiple of these tunnels. And at the same time, you also may want to be able to talk to different service providers out on the internet. If you want your VM to be able to go directly to Windows Update, for example, you don't want it to hop through your own data center to get back out to the internet. So you want to be able to talk directly to the internet. So this is what we really focused on enabling the hybrid cloud, is how do we provide these capabilities. So when we looked at it, we realized, well, there's a few key areas we need to focus on. Number one, we need to make sure that VMM can manage the whole thing. We need to make sure that VMM can manage the lifecycle of the gateway, of the tenants, of their networks from end to end. We wanted to make sure that there was an in-box solution for all the components that are needed to realize these hybrid networks. So we focused on actually building an in-box capability into Windows to actually create a gateway based on Windows Server. And of course, we wanted to expose it all to the tenants and the end users and make sure that the tenants could actually go in and create these own networks on their own and establish the necessary connectivity entirely on their own without having to get an admin involved. So we focused on what's now called the Windows Azure Pack. It was the Windows Azure Services for Windows Server before. It's easier to say now, so I like it already. But we really want to make sure that we had hybrid connectivity in there. So what do we have to start with in 2012 in SP1? I mentioned earlier, at the beginning that we were basing everything we're doing now off of this technology in SP1 or in 2012 releases. In Windows Server, we introduced network virtualization. We already have a routing remote access service role that gives you the ability for a single tenant to establish a site-to-site tunnel. If you want to have multiple tenants, of course, you have to have multiple VMs for these tunnels. We also have Microsoft IPAM as a way to manage your basic environment. I talked a little bit about that in my first session. There's a whole session on IPAM. Go see it if you want to know more about IPAM. In VMM, we introduced the ability to create these tenant networks through VM networks. And these VM networks did give you the basics of hybrid connectivity. So you could create a site-to-site tunnel from this VM network that you created in VMM, but just a single VPN tunnel across, and that was the only connectivity you would get, was this one VPN. We also relied very much on third-party gateways, and you can see the ecosystem around these is actually continuing to grow really nicely. And we'll always see a role for third-party gateways of a variety. Each of these vendors you see here, F5, Huawei, and Iron Networks, each bring their own uniqueness to the gateway solution. F5 is a completely software solution using Windows Server as the host, and their own Big IP Virtual Edition as the actual VM that does the routing and connectivity. I'm going to show that to you in a few seconds. They are ready to ship that today. You can go to their booth and find out more about that. Huawei is shipping, or will be shipping by the end of this year, a device that is not Windows-based at all. It's basically processed the NVIDIA GRE and firmware, and they can basically perform the gateway functionality as a non-Windows appliance. And then Iron Networks. I showed this at MMS a few months ago. They are shipping now gateways to customers. These gateways are entirely Windows-based, based on Windows Server 2012. And they're going to be upgradable. The nice thing about that is they're going to be upgradable to Windows Server 2012 R2 and basically get all the capabilities of 2012 R2 on the same box that they're shipping now. Let me show you the F5 gateway, because that one's new, and it's really nice to see another gateway working. So you can see in this environment here, I have a VMM server. And if I go down to my fabric, you can see I have an F5 Big IP NVGRE gateway already added. They built a provider that plugs into VMM and basically adds this, their Big IP as a gateway. Now, the Big IP is a little bit unique in that it can actually handle multiple tenants through a single gateway. Since they basically create a virtual network adapter for each tenant, they can handle basically as many adapters as you have, which, as you know, Hyper-V is limited to 8 adapters, so their number of tenants will be slightly less than that per VM. But then within the Big IP, then they handle separating the tenants across so that you can't have that multi-tenancy in there. At the same time, because their Big IP is also a load balancer, they can do some additional things as far as what's coming in into the network, being able to load balance and having some NAT-like capabilities on the inbound direction as well, so you can have overlapping address spaces. But they are doing basic routing in their gateway. That's kind of the key capability here. They see this kind of as the first step into the network virtualization world. They're working on a hardware-based solution as well that'll be available. I believe they're targeting the end of this year. So if I actually go up and look at what I have in my VMs and services view, see I have 2 VMs. They are connected to VM networks. This VM Katoso marketing network, it is configured to use the gateway. If I open up the properties, you'll see it's configured to just route to a local network using the F5 Big IP gateway. I'm going to cancel that. And if I actually open up that VM, VM that's connected to it in the GRE demo marketing 2, this one, I can actually open up Internet Explorer and show you that it actually does have real connectivity out, even though it's on its own essentially isolated network. So here's Bing. I can do local time or current time. And you can see that it is real, and it's working just like a VM on any other network, except this network's going through network virtualization, and it's going out through a gateway. So it's currently 3 o'clock in Redmond, not here, obviously. So that's the big F5 Big IP gateway. Whoops, another window open underneath. So it's nice to see additional vendors coming about and seeing the current vendors continuing to grow their capabilities. The other thing I want to talk about on this, before I jump into what's new in R2, is the Windows Azure Services for Windows Server portal, now called the Windows Azure Pack. We introduced the ability to create a VM network or a tenant network, but it wasn't a hybrid network in 2012 in the initial release of it. You created a completely isolated network, which really had limited functionality. I mean, we almost think of it as a proof of concept rather than the actual anything that was really useful. So as we look at what we wanted to do in R2, what are the benefits we wanted to bring to essentially all of you, whether you're a hoster or a internal IT as a hoster, or even an enterprise going to a hoster. We wanted to make sure that for all of you it's cost effective, because if it's cost effective for the hoster, then that means that it'll be cost effective for the enterprise as well, because they're the ones that are ultimately going to be paying for it. We want to make sure that up front the costs were low, so we want to make sure that when you deploy these gateways, they can support multiple tenants per gateway. So you don't have to deploy a VM for each tenant. Now you can deploy a single VM that can support a lot of tenants. I don't think we're ready to say the exact scale. Charlie, you might be able to say something a little more about that. But we want them to be able to support a lot of tenants. And we want them to be able to deploy multiple on there to increase the tenants beyond what a single VM can do as well. We also need to make sure that these gateways are essentially highly available, because downtime in a network isn't tolerated. So we want to make sure that the inbox solution is able to be highly available. So we use the clustering capabilities in Windows Server to achieve that. And we did some interesting things to make it fail over quickly. Charlie will talk about that as well. And we want to make sure that it works with network virtualization and tenants can have self-service. We also want to make sure that enterprise customers, once they're actually using these networks, are able to get the type of connectivity they want. We also want to make sure they get the same experience whether they go to a hoster or to Azure, not just in the portal, which we're giving them that with the Windows Azure Pack, but the actual technology that's used behind the gateway itself at the hosted side. So Azure is using the same RAS technology, the same multi-tenant RAS that's being used in Windows Server now as well. So when you connect your on-premises endpoint into the Azure cloud, you get you can use the same device to connect to the hoster cloud as well, as long as it is the dynamic routing VPN type that Azure now supports. They recently announced support for. So looking at these benefits and focusing on it as an end-to-end scenario, what were the things that we needed to do? Well, so I mentioned we need to make a multi-tenant gateway to make it cost-effective. We need to make sure that the site-to-site VPN is multi-tenant and that you can establish multiple of them per VM network, so that you can have redundancy and that it's reliable. In order to, early on, I mentioned you need to be able to connect directly to service provider networks as well, or direct access to the internet. So we want to make sure we have NAT in these networks as well. So you can have not only just a hybrid network, you can also have completely hosted networks with address spaces that overlap with other tenants as well. So we want to expose NAT in Windows Server Gateway. And we want to make sure you can manage the IP addresses that get used behind the scenes as well. Now, there's a lot of work for VMM and System Center to be able to manage all of this. We want to make sure we could deploy the gateway, configure the host, deploy the gateway, and manage the complete life cycle of these VMs and hosts that you need for the gateway without you ever having to actually go to the gateway itself and do any configuration through Hyper-V or Windows Server. It can all be done from VMM. We want to make sure we can integrate with IPAM so you can manage your address space efficiently. We want to make sure you can integrate with top-of-rack switches. I talked about this stuff, some of this, in the first session, so I'm not going to talk about it again here. But we want to make sure that, as you manage your fabric, you can do it all seamlessly. We want to make sure that for our chargeback system, we can actually route the metrics. You need to be able to, if you're a hoster, know how much your tenants are using and charge them appropriately. And we want to make sure that self-service portals could be built on top of this technology. So Windows Azure Pack uses SPF under the covers. The Service Provider Foundation, any hoster or any enterprise can build their own portal as well using that same REST-based API. And then when we look at the Windows Azure Pack, I didn't update this part of the slide, but if we look at the Windows Azure Service Windows Server, we want to make sure that you could create your complete self-service network from that single portal. So I'm going to walk through basically the entire scenario from end to end, starting with what do you need to do to get your fabric, configured, ready for network virtualization. Then we're going to dive into the gateway. How do we deploy it? That's when Charlie will come up and talk about what its capabilities are. I'll deploy the gateway through VMM, get it up and running, and then I'll show you the tenant experience both from the VMM console, how an administrator would create one of these networks, and a tenant as well. So if we look back at the diagram that I showed you at the very beginning of if you remember 2 hours ago, at the very beginning of my first session, I showed you this network of this diagram of the different types of networks you're going to have. When you introduce network virtualization in the picture, that gateway becomes a network virtualization gateway. It's what bridges and does the encapsulation, the decapsulation. And you have a physical provider network. So you need to have a logical network for your provider network that gives you the IP addresses that will be used to send the packets out on the physical wire. But then each tenant gets to define their own virtual networks underneath that. Those are VM networks. They don't get a logical network to match it. Some of the key things you have to do, and some things that have changed in R2 now, when you create your VM network, you have to basically say you want to allow network virtualization. Or sorry, when you create your logical network, you want to say you want to allow network virtualization on this logical network. So that'll tell VMM, okay, this is a logical network that's available, so that when somebody creates a VM network and says they want a specific logical network, we'll know to give them the option for network virtualization. You also need to have a static IP pool on that logical network, because VMM has to be able to allocate those addresses for the host to use. One thing that's changed, I think I mentioned this earlier, is that the network virtualization filter, in order to allow it to coexist with forwarding extensions, moved from a filter outside the virtual switch into the virtual switch. So now it's in the switch itself. So you no longer need to enable that separately as a separate step. And then one other thing that I wanted to mention here, because I've been stung by this a few times, you can use Windows Server 2012 and 2012 R2 in a mixed environment, and both have VMs that talk to the same VM network and the same network virtualization policy. But on the 2012 host, you need to have that KB 2779768 that fixes an issue with the packet format in Windows Server 2012, so that the two versions of Windows Server can talk to each other. But then you can have a mixed environment. You don't have to have all of one type or another. So just really quickly, I'm going to jump over to my demo environment again, number 8. And just show you, yes, this is a demo environment similar to the one that I showed you earlier. I already have a logical network created for my provider address space. This I tend to call a tenant network. It'll contain the tenant virtual networks, but it's a single logical network that has an address space that's used for sending the packets on the wire. So I created this in the exact same way that I created my management network, and the exact same way I created my, my external network, except one key difference is if I go into the properties, I basically check this box off. This says allow VM network created, use Hyper-V network virtualization. If you went to my earlier session, then you also heard me say that forwarding extensions can now implement their own network virtualization. And if you do have a forwarding extension that supports that installed, you would see actually that here as a choice to say that if a tenant comes in and creates a network, that's the technology that will get used to create it. So I only have Hyper-V here. I don't have any forwarding extensions on this environment. Then other than that, it's just like any of my other sites. The only thing is I have a static pool and a IP address pool so that VMM can allocate the PA addresses, the provider addresses for the physical network. Okay. So the next step is to actually enable the hybrid network connectivity, right? So you've got your basic fabric. I can deploy VMs now, create VM networks that use network virtualization. They can talk to each other. But if you want them to be able to get outside, then you need a gateway. As I mentioned, there's going to be a role for third-party gateways. Windows Server is a great starting point. We think it'll scale really well. There will be Windows-based gateways in the future, and we think there'll be hardware-based gateways. In addition to what Huawei is going to be offering, additional vendors will be bringing those. But really, the Windows Server gateway we think is the way that a lot of our customers will be introduced to network virtualization and will really begin to grow their environment from. So I've got Charlie Wen here. He's going to talk about what the gateway itself will do, and then I'll come back up to actually show how to deploy it in VMM and get it up and running.
Thanks,
Brad. Charlie.
Thanks. I'm Charlie Wen. I'm from Windows Core Networking team. What I'm going to talk about today is what we actually implemented in the platform, as known as the inbox gateway. So hopefully, we'll make some of the new concepts easier for you to understand, and when the time comes when you deploy and try it. So before that, I think I will start with what do we have, what do we support in Windows Server 2012. So we talked a lot about Hyper-V network virtualization, and we also support the side-to-side VPN. Now, we deployed this, we heard from customers, we heard from Azure, and we learned a lot of lessons. One thing we heard is when you deploy Windows Server 2012, and to enable this side-to-side VPN, you have to spin off one VM. Remember, our gateway runs in a VM. You have to spin off one VM for each tenant. Okay. And second limitation we learned, second lessons we learned is to enable the routing. Remember, Greg mentioned the routing between the two sites. You have to do the routes configuration on each side. You have to do the static routing configuration on each side. And also, for enable this, because this is a side-to-side VPN, you have to enable security profile and all this. And to enable that, you have to go through all the step-by-step manual configuration. And also, we in 2012, when you establish this side-to-side tunnel, when you have a tenant that has a virtual network, and the virtual network needs to connect to the internet, the traffic has to go through the side-to-side tunnel back to the on-site on-prem network before it can go to the internet, because we don't have an inbox data center scale NAT in 2012. So these are the lessons we learned. These are the feedback we heard from the customers. So these are the areas we improve for 2012 R2. So the first thing we do is we enhance our platform so that you can actually consolidate multiple tenants on a single VM. Okay, this is a pretty big deal because once you can support, imagine you have 1,000 tenants, right? With 2012, you have to spin up 1,000 VMs, one for each of the tenants. With this, you can probably spin off on order of tens, maybe even. Really, you spin off user far less VMs to support a lot of tenants. That reduces the cost. So that's actually enable service provider to reduce the cost and make many things possible. I will talk about it. The second thing we do is we enable, so remember the gateway actually connects two networks, right? So the traffic goes through the gateways. So high availability is really critical. So we actually enable something called failover cluster. The gateway runs in a VM, and we allow you to enable failover cluster between the gateway VMs. Now remember, like 2012, you have to do the static routing configuration. What we introduced in R2 is actually you can learn a protocol. Many people, if you're familiar with a routing protocol, something called a BGP, control protocol. And the BGP control protocol can exchange the routing information between the two networks. So you don't have to do this static route configuration anymore. And the last but not least, we introduced a data center scale multi-tenant NAT. So I will actually dive deep in each of these areas and give you more information. But before that, I think I want to give the demo. So I just want to quickly go through the demo. So I'm going to show a failover gateway. I'm going to put the two gateways in a failover cluster. And this is a multi-tenant cluster because behind the gateway, there are two web servers, and one for each tenant. I'm going to connect to the web servers from a client machine outside of the hosted cloud. I'm going to download file, and then I'm going to fail over the active gateway. And you'll see the file download actually continues. And with that, let me change to number 8. Okay. All right. Okay, so another one. So what you are seeing actually is the Hyper-V host that hosts the gateway, and the gateway runs in a VM. I need to log in again. All right, so the first thing I want to do is I want to just quickly show this gateway hosts multiple tenants, and we introduce a new, if you use a PowerShell, some of you may just try to play with these new features using PowerShell. That's why we do this. You'll see actually we have these 2 tenants. Okay, this is a new command. The next thing, I'm going to move to the web servers. Remember I mentioned that there's 2 tenants, and each tenant has its own web server. And this is the web server you see. And because they run on the Hyper-V network virtualization, and you can see they have the same IP address, right? 10.0.1.101, 10.0.1.1.101. They have exactly the same IP address. Each tenant can bring its own IP address. And now I'm going to move to the client. Now, for this client, remember, I'm just going to open a browser and connect to the web server. And you can notice the IP address is kind of a public IP address because the connection actually goes through a NAT to the web server, a multi-tenant NAT. No. Okay, so that you have each tenant has its own IP address. So I'm going to download a file. Yeah, that's not supposed to happen. Okay. I'll download file on this side as well. Okay, you can see the traffic actually is going. Okay, so now I'll move to the gateway again. This is the active node of the two node cluster. Okay, so just quickly show this is active node, and host name is this, and then I'm going to do this to move the node. So you can see we actually move the node. Actually, hold on a second. Move to the second node. Okay, so we move the node in around like 2 seconds. If we go back to this connection, and you can see the connection is still running. We're still downloading files on both sides. So we already failed over the node to the standby. And if you quickly log in, okay. So you'll see this node actually takes over. And in doing so, we actually fail over in an order of seconds. And we actually, because we fail over so fast, the end-to-end connections actually remain alive. So let me move back to the presentation. Okay. Yeah, we'll do that next time. The reason actually I want to show you the fail over time. Okay, so far we spend a lot of time talking about hybrid network. I want to spend some time talking about private network because our gateway, our inbox gateway is actually very useful for the private network as well, for the private cloud as well. Now with HMV, Hyper-V network virtualization, you can actually do many things. You can abstract the physical network. Now imagine this scenario. Imagine you're a company and your engineering team wants to do something. They want to configure servers. They want to set up their own lab. Now, in the past, the engineer team has to open the ticket, right? And the ticket has to go to the networking team. The networking team has to do the cabling configuration, all this. And now with HMV, you can actually do all this by the server team, by the engineering team by themselves. Now, the thing is, when you configure this VM network, for this company, there are a lot of services that are still running on the physical network, right? There's SharePoint, web servers, and the DNS. And as Greg mentioned, once you use HMV in 2012, essentially they are very complete islands. They are just completely isolated. And with this Hyper-V, with this forwarding gateway, essentially we can bridge in this physical network and the Hyper-V network, virtualize the network. Now you say, now we have a hybrid cloud and we have a private cloud. What if I want to use them both? Well, actually it works both. It works in both environment, the forwarding gateway. And to make things even better, let's say you actually have existing investment in some third-party solution, VPN solution. You can actually connect the forwarding gateway to the VPN router. Right? So in this picture, you actually have hybrid networking and you also have a private cloud support. So with that, I'm going to talk about, so you heard of the multi-tenant service. So you have a multi-tenant site-to-site gateway, multi-tenant NAT. So I'm going to talk about what we did in the stack. So what we did in the stack is actually we introduced something called a multi-tenant networking stack. Now this is a picture of 2012, right? It's a pretty TCP/IP stack, and you have a network services running on top of TCP/IP stack. What we did in R2 is actually we introduced some new concept of called compartment. So for each tenant, you will create a compartment. You have a create compartment for a tenant VM network. And in this compartment, you can create IP address. You can create IP interfaces. You can create IP address, and you can create routes. And these interfaces, address, and the routes are completely isolated from each other. That's how we can support HMV. And also, you notice there's a default compartment. And the default compartment actually has interfaces connect to the external, the public network. And you can see we actually have two groups of network services. And we have existing network services. And we have also multi-tenant network services. And the existing services actually talks to the default compartment. And the multi-tenant network services actually I will talk about actually can talk to each compartment. So just a quick recap. With this stack change, with the change in the stack, we provide isolation for each tenant because each tenant will have its own VM. For each VM network, will have its own IP compartment. And it's completely isolated, so you can bring your own IP address. And it's enabled through the Hyper-V server. It has to be enabled on Hyper-V R2, 2012 R2. So I mentioned about the multi-tenant service. I'm going to talk about two multi-tenant services. One is a site-to-site, multi-tenant site-to-site, and the second one is a multi-tenant NAT. So I'll go into provide some more details about the multi-tenant site-to-site. So let's say let's start with onboarding a tenant. Let's say in this case a Northwind VM network. You create a VM network and you create a corresponding compartment on this gateway. And let's say the tenant wants to has a remote site and wants to have established connectivity between the VM network and the remote site. So the host element creates a site-to-site interface in the compartment. And then remember I mentioned that in the default compartment, we have these public-facing interfaces, right? For the remote side, it will dial into the public IP address. So when we receive a packet, we'll take a look at it. Go back, step back. Right. The information, the packet comes in, has the information, authentication information. authentication information could be machine certificate, could be pre-shared key, or could be EAP. And based on this information, we actually would direct the traffic to the corresponding compartment. So we know the traffic comes from the north wing, and we'll direct the traffic to the north wing compartment and then connect to the north wing VM network. And similarly, let's say we have another tenant, Contoso. We can onboard the Contoso in the same way. And in this case, let's say Contoso has two remote sites. So we just create two tunnels, two side-to-side tunnels. They both connect to the same compartment, Contoso compartment. So just quickly show how the packet works. The packet comes from the VM network. We'll go to the compartment, and then remember there's a routing table in each compartment, and based on the routing table, the packet will go to the right remote site. And this is how multi-tenant side-to-side works. And we support the rate limiting. For each tunnel, you can rate limit traffic on either direction, so that you actually provide some SLA to the tenant. So the second multi-tenant services I'm going to talk about is multi-tenant NAT. So in this case, let's say you configure NAT for Contoso. What happens is, let's say the VM network initiates outbound connection to the internet. So the packet will come to the compartment, and the compartment, the tenant compartment will send the traffic to the default compartment where the NAT is configured. And the NAT there will do the translation before it sends the packet to the internet. Okay. So with NAT, we also support the inbound connection. Let's say a tenant actually has a web server hosted on this VM network. So what we can do is, I missed one thing. For each compartment, for each tenant, you can configure. You can bring its. You have to configure. Provide a unique IP address for each tenant. Yeah. So that's what the NAT. So the question is, how does a private IP address talk to a public IP? That's what the NAT is used for. It does an address translation. We can talk more about it if we need more details. So just quickly, inbound connection, you have a web server connection coming from the internet. Again, comes to the NAT, and there's a static mapping that directs the packet to the right compartment. Okay? So that's, and when it comes to the right the compartment, and the routing table will say to which VM, to which server it will be, the packet will be sent to. All right. So I mentioned about BGP. I want to give some illustration about BGP, how actually BGP is used in the side-to-side case. Now remember, in 2012, you have to configure the static mapping on each side. This is actually pretty lot of overhead to do that, especially if you're a customer, you have a multiple remote sites. So with BGP, the control protocol will do the routing information configuration exchange. Right, so side 1, side 2, and the VM network will exchange, what's the routes available on each side. So once it does, BGP does that, the traffic basically will go according to the best route selected by this control protocol. Okay, in this case, let's just say the connection, something happened between side 1 and the hosted cloud, right? And because BGP is still running between side 1, side 2, and the hosted cloud, you actually redirect the traffic from side 1 to the VM network in the hosted side. And all this happens automatically. Right? You don't have to configure the admin. The hosted admin doesn't have to reconfigure. The side 1 admin doesn't have to configure it. Everything happens automatically in runtime. So that's BGP. That's just a quick recap. So the tenants can be exchanged. Remember, this is a multi-tenant, the multi-tenant BGP. So we support BGP can be run on different tenants remote side. They all exchange, all the routes are exchanged on the multi-tenant gateway, inbox gateway. And because we cannot predict what address is used on each tenant, and by definition, we have to support overlapped IP addresses. And it's integrated with site-to-site VPN, so that when the VPN tunnel goes down, BGP will know and re-advertise the routes through other routes available. So that's BGP. So last thing I want to talk about is clustering for HA. So when you use a VMM to create the guest cluster, create a form of failover cluster between the two gateway VMs, it's actually one-to-one redundant. One is active, one is standby. So remember that the connection between the two networks actually is end-to-end. The end-to-end connection just go through the gateway, right? It actually doesn't have any states on the gateway. So that's why when the active, let's say an active node fails, the active node can be detected immediately. And the site-to-site tunnel will reestablish. Okay? The site-to-site tunnel will, from the remote side, will connect to the new node in the cluster. It happens so quickly, and that's why you see from the demo, the end-to-end connections stays alive. And that's how we actually provide HA, high availability, to users. So with that, I'll hand it back to Greg. If you have any questions, I will be around after the session. If you come, free to come and
all right, thanks, Charlie. I was in the back checking email, so I'm back. All right. Back to VMM. There we go. All right. So that's how it works internally. I mean, Charlie gave you a good background on really what the gateway is going to do. Now let's talk about how you actually get one of these stood up and running and use it. As I mentioned earlier, you shouldn't have to ever go into the gateway itself, the host or the VM, to actually configure anything. We want to do it all through VMM. You're going to start off with a standard Hyper-V host that you're going to deploy using any method you want. You can use VMM, bare metal deployment. You can stick an ISO in the machine, get Hyper-V on there. You need to mark this host as being a gateway host, so you have to dedicate it to gateway functionality. The reason for this is because the plugin that we use to talk to it is the same plugin we use to talk to third-party gateways. To VMM, this is actually an external appliance still, but we do the full configuration. The other reason is that generally these gateways will be edge devices. You're going to have essentially untrusted workloads facing the outside. If these are facing the internet, you need to deploy these as untrusted hosts, and so you don't want your general VM workloads on those. You then deploy your gateway VM onto there because it's this combination of Hyper-V working together for the network virtualization policy and the VM that's actually doing the gateway functionality that Charlie just showed you. Once you actually deploy the VM, enable the necessary roles on it, and this will all be done by the service template. So once you've deployed the service template that will configure the VM, you then add it to VMM as a gateway. So VMM knows that it's a gateway and can then start using it. There's some final configuration where you map the network adapters to which logical network to use for the different networks. And that basically, at that point, is basically ready to use. You can start creating tenant networks on top of it and get it up and running, and basically up and running. The longest step in the process is basically the VM deployment customization. Now, this will be available in preview, but some key functionality that won't be ready in preview yet as far as VMM's configuration deployment yet is the high availability that Charlie just showed you. You're going to have to wait for RTM for that. And then also the private cloud forwarding in the gateway is not there yet either. We had to make some changes in order to handle the compartments. And so that'll be ready in time for RTM. So what I'm going to show you now is actually how you deploy this gateway. I've got a Hyper-V host that I've already deployed, that I have up and running, added to VMM, and I'm going to deploy VM onto it that will become the gateway. And so basically the first step is deploying this VM onto the host. And it's the service template. It's going to do a few things. It's going to create the VM with 3 virtual network adapters. You need 1 for management so that VMM can talk to the gateway. That's what I label as infrastructure on here. You have 1 adapter that's going to point to the outside world, your external network. This could represent your connectivity to the internet or your corporate environment if this is a private cloud. And then a 3rd virtual network adapter for your tenant backend. The tenant backend essentially is your network virtualization network. It's the one I showed you at the beginning where I enabled network virtualization on it. So these are the three basic networks that you need to have feeding into this VM for it to act as a gateway. Once you've deployed it, you add it to VMM as a gateway. So VMM needs to know that it's not just any VM, it's a gateway VM. So you have to add it to VMM. And as part of adding it, that's when VMM will start to talk to the VM through WMI. It'll configure it and enable the multi-tenancy. And then the last step is you set the connectivity to basically say for each of the VNICs on that VM, which network is that VNIC connected to. And that's really where VMM really finalizes the configuration and makes it ready to use. You're ready to then try it out, test it, and make sure it actually works. So let's actually jump into my demo environment and deploy a gateway. All right. OK, so here's the VMM server. I've already got my network set up. So here's my management network. It's called Fabricam. My external network, you can see it has internet, the equivalent of internet routable addresses. And I have my tenant network for network virtualization. So the first thing I'm going to do is I'm going to go to my library where I have a service template already there. This service template will be available to all of you. It'll be available. We'll put it on TechNet for the preview, and we'll have it in the box for RTM. And I'm going to open up the designer and show you what it contains. So it's going to open up the template designer, and basically it's going to show you there's a VM template in here. Oh, did it go off? Oh, there it is. There's a VM template in here with 3 VNICs, and I have currently have the NICs hard-coded. I actually have another version of this. It's a little bit newer that will deploy this gateway in an untrusted mode as well. So if I actually go to this one here, because as I mentioned earlier, these will generally be untrusted hosts and VMs. So if I open the designer this time, this is a slightly newer version of the template. This is the version 3 template that we're working on that it uses configurable service settings for the network. So when you import it, you'll select the networks then that map to those VNICs so that our placement algorithm runs. It does a few other things internally as well in the VM when it does customization. It'll run a script that'll rename the adapter so that you know which adapter is which network it's connected to. And then it also configures it as a basically non-domain joined machine. So the host, you'll add the host to VMM as an untrusted host, same way you would any other untrusted host. And then you deploy this VM to essentially the same, in the same untrusted mode. And then we talk to it through using certificates for authentication rather than using AD. OK, and you can see these are the roles that we enable as part of the service template. I'm going to go now and I'm going to deploy. The version 1 because this one isn't quite ready for deployment. So let's deploy the version 1. This one already has the networks pre-assigned. So I'm going to do gateway VM3. I'm going to go into my edge host group. This is where my gateway host is located. OK. So the deployment wizard is going to come up. I'm going to have to hit refresh so that it will recognize the host. It'll run placement now. And pick the gateway host as being suitable for this VM. So this will take a few seconds. There it is. And it's going to be called gateway VM3, and that is going to be the VM name 2 as well. And so this is going to go out and start deploying the service. Now this takes about 20 minutes. So the reason why it's gateway VM3 is because I already have a gateway VM2 deployed. It's freshly deployed out in the same host. Just like a cooking show, I'm pulling another one out of the oven. And here it is. This is a service. So if I go to my services view, you can see Gateway VM2 is a service that is created and already up and running. So this is the VM that I've already deployed to save time. So if I go now to my Fabric view, the next thing I need to do, one other thing that I've done, and I'll show you this through PowerShell, is when I added the host, I marked it as being a network virtualization host. So for PowerShell to come up. There we go. So if I do get scvm host, is fab gateway 1. Do that right. You can see there's a property called is dedicated to WNV gateway. All right, fine, I'll do it the hard way, or the easy way. FT. There we go. So that's set to true. So this basically tells VMM, don't deploy any other network virtualization workloads on this because it is for the gateway purpose. You set that by doing just a set scvm host dash is dedicated to network virtualization gateway, and you set it to true. And you pass in the VM host name or host object as well. And so that'll basically set it as a gateway host. So now I've got this VM already deployed, and so now I'm going to actually add it to VMM as a gateway. So I do that through the network service wizard. I'm going to do add resources and network service. This is my gateway VM2. So you can see we have a number of plugins that we ship in the box now. This is the top of rack switch plugin that I talked about earlier. So you can add a Tor. You can add IPAM server, and here's where you add the gateway. So I'm going to select the gateway plugin so we can add the gateway. You, of course, have to have credentials to be able to talk to it. Then a connection string. This is where I wish I used copy-paste equals fab. So what we need to know through the plugin now is which host it's on and which VM to use, because this host could have multiple VMs, multiple gateway VMs. This is gateway VM2. Okay. Now, if this was an untrusted host, untrusted VM, we'd review the certificates to make sure they were the machines that we thought we're talking to, and you only then we would insert the certificate into the trusted store. But since these are domain joined machines, we don't need to do that. I could test the machines, test the connection to make sure I got everything right, but I have confidence I did it right. Compute. And scale it to specific host groups. This is going to be available to my compute hosts. If you had multiple racks and you wanted to say that this gateway only serves a particular rack, then you could scale it to the host group for that rack. And finish. So this will actually run for a few seconds, and then you'll see it show up here as a gateway, as a network service. So there's the gateway, so we've added it. Now, what we've done as part of adding it is we've gone out and queried what network adapters are in there. So now if you go into the properties, you can see this connectivity tab. And in this connectivity tab is basically where you say, so the front end is connected to this logical network, and also which adapter to use as the front end. So I know that 8802 is my internet routable address, so that's my front end. And I'm going to say it's connected to my external network site. And then the back end, I know that it's a 1060/64 subnet. It's not the 169 because that's didn't get assigned an address. The 169 is on the tenant network where there's not a DHCP server, so it didn't get an address. So I know that too. You can use a number of methods to figure out which one is the right adapter. You could even compare the MAC address too and see which VNIC is the right one if you needed to. So I'm going to go and connect that to my tenant site for network virtualization. Hit OK, and that's it. I've now basically added this gateway to VMM. It takes probably about a minute now at this point for it to go, enable the compartments, set up the multi-tenancy in the compartments, and get this gateway VM basically ready to use. So I'm going to go now and actually have a third gateway that I've already added. That's this gateway VM1. I'll actually show you it being used by VMM. So the next step as the admin is I'd go in and I'd actually try out my network to make sure it actually works. So I'm going to do that now. So I'm going to go up here to my VMs and services view where I have my VM networks. You can see I already have a few VM networks here, a tailspin, a wingtip. I'm going to create a new one. I'm going to call this my TechEd network. It's going to be on the tenant logical network. See, now I have the options for Hyper-V network virtualization, so I'm going to select that. I'm going to add a subnet. I'm just going to use NAT for this one because I don't need to worry about overlapping. Pick whatever subnet I want. And now I have a number of new connectivity options. These weren't here in our SP1 release. They're new in R2. I can basically say I want a VPN tunnel. I can say I want BGP. But for this one, I'm just going to say that I want to use NAT and do direct routing through NAT. I'm going to use my gateway VM1. And I'm going to say which IP pool I want to pull an address from. So VMM will automatically pull an address for this NAT connection out of that IP pool, or you can type a specific one here if you want a specific one. I can also, and so this will give me basically outbound access from this VM or from this network. I can also add inbound access as well if I want to have a web server, for example, on port 80 for inbound. And then I want to map that to 10.0.0.2. Of course, this assumes that I'll actually deploy a VM and assign it that address. I can come back in and pick this stuff later if I wanted to. Yes, tenant will be able to do this as well. So I'll show you the tenant view of this at the very end. Finished. So this is going to go out. It's going to create the VM network. It's going to configure the compartment in the gateway. So there's my TechEd network. Last thing I'm going to do is create an IP pool. My IP pool. Oops. I'm going to go ahead and use all the addresses. So since I do have NAT available, I don't need to do the gateway because you will use the network virtualization gateway. Since I do have NAT available, I can enter in an IP address for the DNS that's outside of my current, that's on the routable space. So I can do 8.8.8.8 as my DNS server. And it'll basically do the DNS lookup through NAT. And that's it. This network is now ready to use. I can connect some VMs to it. I already have a VM connected to my Tailspin network. Let's see, this one here. So I can do ipconfig. You can see this is on a 10.0.0.4 network. But I can also ping. Actually, I think I have it in my up arrow. There we go. So can use DNS from the outside. I can ping an address outside of my own network. And I can even get to a file share through the gateway as well. I can open up some random file, copy it to my desktop. And you can see it basically just behaves like a normal network from the external test. So see that it actually does work. All right, so that's gateway deployment. So basically, that's all there is to deploying the gateway. No configuration that you have to do in the VM, nothing you have to do on the host. You can do it all through VMM, get up and running. As you reach additional capacity, need more capacity, you can basically just deploy more VMs until you reach a bottleneck of either the CPU or the network bandwidth basically reaches its capacity. So the last thing I want to talk about is, basically the last layer. How does a tenant actually get access to this? The primary way is through the Windows Azure Pack. And basically, we want to make sure that tenants can create their own networks entirely on their own, configuring multiple VPN tunnels, configuring NAT, and doing it in a basically easy-to-use portal entirely on their own. We also want to make sure that everything that they can do through that portal is available to somebody building their own portal. So all of this functionality is exposed through our SPF layer. So you can use a REST-based API to create your own portal. So if you want to do something different from what the Azure Pack does, then you can do that. And one last thing I want to mention that we've enabled for tenants in particular is the ability for a tenant, if you give them this option, it's controllable through a port profile, the ability to basically specify their own IP addresses for a network virtualization network. If you're familiar with SP1 and you were in the previous session to this, you know that you couldn't actually, VMM had to assign the IP address to the guest. You couldn't define your own. And the key limitation of that was that guest clustering wouldn't work because that virtual address would fail over from one VM to another on its own. And since VMM didn't assign the address, it wouldn't work. Now we'll be able to support that. So the basic scenario for tenant self-service is essentially the tenant's going to go to the Azure Pack portal, and they're going to basically create their network. That portal will tell VMM, OK, create this network, basically do what I just did through the VMM admin console, which will then configure the gateway. Last thing they have to do is they have to basically tell their on-premises end, if it is a VPN tunnel, they have to basically do that configuration for on-premises to get that final configuration done. And then they'll get the VPN tunnel established. For doing that final configuration, you can actually follow the basic instructions. Because as I mentioned earlier on, Azure is using the same technology for their gateway, for their dynamic routing VPN gateway in particular. They're using the same technology, so you can actually use the same configuration scripts for Juniper and Cisco devices, and even RAS as your on-premises endpoint, and can use those configuration scripts and instructions to connect to the hoster network. So let me jump over to my demo environment one more time. So wait for it to refresh. It timed out my connection. While that's refreshing, there it goes. So you can see I'm actually using the hybrid identity capabilities of the Azure Pack. So I'm actually logged in as my own Microsoft identity, and it's using the AD Federation to do that. So it's refreshing in. So this will come up and be the networking panel. Which I can probably click it now. I'm probably going to look too fast. I think our servers are tired after a long day of demos, so that's why it's slow. So here you can see I have basically 3 networks that I've already created. I'm going to go ahead and create a new one right now. I'm going to create new virtual network, and I'm going to do custom create. This will give me the full set of options available. I'm going to call it my TechEd network. Choose IPv4 or v6. I can specify what DNS server I want to use, and whether or not I want to have NAT or VPN. So I'm going to actually do both, because you can do both. The gateway subnet is just a routing subnet that's needed to get from your virtual networks into the outside world. So you just need to interchange this if it conflicts with one of your own subnets that you use in your own organization. We generally think this one isn't used very often. And I'm also going to enable BGP just to show you those options too. So we predefine it. We default to the address space 10.0.0.0. You can change it to whatever matches your organization. I'm going to just leave it as that default. And then you give it the connection information to your on-premise endpoint. So this is my headquarters. My VPN IP address will be 8.8.8.99. You give it a pre-shared key, my key, and then the address space is going to be used to route. So if you do have multiple VPN connections, we have to know what subnets are available on each one of those connections, so we know how to set up the routes to each of those sites. Now, this is only for the initial configuration. Once BGP is up and running, then those sites can get updated. Those routes can get updated dynamically. But you do need to have at least one route there to kick off the initial routability of the packets. Okay, I left out a dot. And so here's the BGP configuration. So this is iBGP, so it'll configure your, it'll talk with an internal BGP peer. And you would give the address for that. Oh, this would be 10.0.1.2. ASN. And then I click the checkbox. And that's it. This is going to go out. It's going to configure that network. It's going to enable NAT. Now, I haven't defined any NAT rules yet, but it'll enable outbound NAT access on that. I can actually go into one of these networks while it's creating the one still working down here. You can see. I will go into demo 3. Actually, let's see what this one has. You can see we have a link so that if a hoster wants to provide those same VPN scripts that Azure provides, they can do that. So this link is customizable by the hoster. But this basically gives you your network dashboard. You can see there's a panel for NAT rules, for site-to-site VPN. So if you need to add additional connections, you can go to the site-to-site VPN panel and select that. I will take a risk and click rules before it's finished. OK, so I haven't defined any NAT rules yet. I can do that now. I can do add rule. Basically say this is my web server, much the same way I did through the VMM console. They do one nice thing is if you have VMs already created, you can actually select which VM you want it to go to. I don't have any VMs on this network, so that's blank. So you don't have to actually know the IP address. You can just say, go to this VM, and it'll connect you there. I'm just going to cancel out of that. If I do want to have additional site-to-site VPN tunnels, I can add those here. So here's a single tunnel. I can add an additional tunnel or change my pre-shared key, that sort of thing. And then I have additional configuration options. I can go through and see what my address spaces are and all the additional details of this network. So it's fully manageable. You can see my TechEd network came up in the meantime while I was talking. So it's now up and ready to use as well. So I can create a VM, connect it to this network, and I basically have full connectivity outside, both through NAT and through my VPN tunnel. And, oh, well, there was my demo. I already did that. So, closing remarks. So I think we do have an end-to-end solution. That's what we aim for. We have full deployment. We have configuration. We have a great variety of connectivity. We think it's very easy to deploy, configure, and use. So I hope you think so too when you get it in your hands in a few weeks. Try it out. Let us know what you think if it meets your needs. With that, I want to thank you all for spending the time with me. If you made it through all 3 hours, thanks for that. I'll be at the Ask the Experts for the next hour or so. So if any of you have questions you want to ask me or just want to chat about networking in general, any feedback you want, feel free to stop by. Ask any questions you want. You can ask questions now, too, if you want as well. So thanks, everyone. Yes?
Sir, for the HA cluster, if you company changes names, server gets imported to the active node, is it passive sync, or is that manual talk status?
So the cluster deployment will be a 2-node cluster, right, with a 2-node guest cluster inside. When you add that to VMM, the cert will get basically installed into the trusted people store in the VMM server. So VMM will know how to talk to that. If for some reason that cert changes, then you just need to re-import into the store. You should be able to do it manually if you just export it from the machine and manually add it. And then, yes. Oh, if you shut down one node, yeah, it'll move to the other one, and then you can do whatever changes you need to on the primary.
Okay, got it.
Yeah, and same thing for maintenance. If you need to install any updates on any of these machines, the idea is you just fail over the node to the other node, install your updates, and then you fail back and install your updates on the other one. So you have to do rolling update. See, Ryan?
So the gateways are put in a work group and not a domain?
That's the general idea if you want them in an untrusted mode. So basically, you put them in work groups so that if somehow they get compromised, hopefully they won't. We do a number of things to harden them. But if they do get compromised, you don't want them joined to your trusted domain as the VMM server, because then they can go off and wreak havoc.
But how is it that you're able to cluster them? Doesn't clustering require nodes to be in a domain?
So there is a new mode for AD-less clusters.
Okay.
So that's what we're using.
Well, yes, but don't they have to touch the...
Yes, so it's an R2. This all requires R2. So this is all R2.
Okay.
And for the VMs, we'll use shared VHDX. You don't have to have any shared storage. You don't have to have like a...
Right. So domainless clusters.
That's the plan.
Okay.
We're still doing the work.
All
There's a small chance that... But the intent is that, worst case, you'd have to go into an untrusted cluster, right? You'd have to do a partial trust cluster, right? If for some reason, in our ramp up to RTM, it doesn't work. But that's the design, is that we'll use AD-less cluster. So in 2012, you basically have to go to one of the partner solutions. So you can go to F5 and get their software solution. They have an eval version available that you can get and actually try it yourself. And then, or if you were ready to put it in production, you can go to any of the vendors that have production solutions. Iron Networks and F5 are the ones shipping now. Huawei by the end of the year.
So gateway is required for the external network if you have just virtualization host or hyper-V host, and you want to enable the network virtualization, use it, you don't need it.
You don't need it if you just want the host to talk to you. Oh, the other thing that I should mention is the gateway has to be 2012 R2. The hosts themselves can be 2012. So the gateway itself, if you're using the Windows gateway, it needs to be an R2 host and R2 VM and VMM R2. But then you can use all your existing 2012 hosts still and have all their workloads. As long as you get, were you in my first session?
Yes.
Then if you only get the KB you need, then those hosts can talk.